the mass which is kept on the 12 kg, the mass which is kept on this 12 kg object should be 3 kilogram, but unfortunately it is typed and printed as 30 kilogram. It should be 3 kilogram. So then what is the total mass of the system here? What is the total mass of the system? Let me take it as capital M. Hello?
17 kilo.
3 plus 12. So it means how many kilograms
15.
here?
15.
Yes. So that is 15 kilogram. Then the weight of the total, weight of the system acting downward as capital Mg. I have taken capital M as the total mass. Therefore, the weight of the system is acting downward, capital Mg. A string goes over a smooth pulley and it is connected to a cylinder like this or cylindrical object like this. Its mass 10 kilogram, it remains unchanged. So this simple Mg remains unchanged. The new tension will be, let me mark it as T2 Newton. So when a string does not have a mass, it has the same tension everywhere. Last week we proved it. A string has the same tension force everywhere when it does not have a mass. But if the string has a mass, the tension force here will be T2, tension force here will be T3. But here it is given that string is a light string. And this is the surface where the object is kept. Right? There will be a friction force. Let me mark the new friction force as FB Newton. So what is FB Newton dear? The new friction force. The new friction force. How do we find the friction force dear? Somebody please give me. The friction force acting on a moving object is said to be a kinetic friction force. What is the equation that we use to find kinetic friction force? Somebody please tell me.
F equals mu r.
Yeah, friction force. Kinetic friction force equals mu r. What is mu dear? What is mu?
Coefficient of friction.
Coefficient of friction. The coefficient of friction change when the surface is changed. So different surfaces will have different value for mu. So we can't say the value 0.4 is common for all the places. So it is given in the question that the coefficient of kinetic friction between this box and the surface is 0.4. But in other questions, it will be changed. So let me mark the new normal reaction force given by the surface as R2 Newton. Right. Please draw this figure. In addition to the previous figure, please draw this one. After that, let's discuss it. Start there. Okay, did you draw the figure here?
Yes, sir.
Right. Now you see the system of box and the new mass not moving upward. They are not moving upward, at the same time they are not moving downward. If R2 force is bigger than mg force, the system should be moved up. If mg force is bigger than R2, the system should be moved downward. So it's not moving upward and it's not moving downward, mean this R2 and mg forces should be equal. So please write, as there is no vertical motion, of 3 kg and 12 kg objects, as there is no vertical motion in 3 kg and 12 kg objects, as there is no vertical motion on 3 kg and 12 kg objects, comma, the vertical force acting on them should be equal to the vertical downward force acting on them. Vertical upward force acting on them should be equal to the vertical downward force acting on them. Vertical upward force acting on them should be equal to the vertical downward force acting on them. Did you write?
Yes, sir.
Right. So, but in the examination, we do not write that sentence. In the examination, we don't write that vertical upward force acting on them equal to vertical downward force acting on them. We don't write like this. We directly write R2 equals capital mg. So capital M is 15, G is 10. So you will get 150 Newton. 150 Newton. Right? Please write this. After that, let's try to find the new friction force. Write it. After that, let's try to find the new friction force. The new friction force is mu R2. Can you do the rest and find the new friction force, dear? So what is the new friction force, dear? They have given the value of mu as 0.4. R2 is 150. R2 is 150. 0.4 can be written as 4 by 10. This is 150. You see, it's clear that this 0 and this 0 cancelled out. Now 4 times 15 is 30 and 60. 60 Newton. So what is the new friction force, dear? What is the new friction force? Lamai?
50 Newton.
60 Newton. Very good. The new friction force is 60 Newton. Right. Can somebody tell me the next thing that we should do, dear? What should be the next step? Yeah, we should apply, look at board, only to 3 kg plus 12 kg combination. Only to 3 kg plus 12 kg combination horizontally into the right hand side direction, we can apply F equals ME. Only to this combination. There are two horizontal forces acting on the combination. This T2 and FB. How many horizontal forces acting on the combination here? T2 and FB. Therefore, the total force acting into the right hand side direction is T2 minus FB equals mass is 3 plus 12. The acceleration is A. So T2 minus FB, the new friction force we have found. New friction force means FB. New friction force we have found as 60 Newton. So 60 Newton, T2 minus 60 Newton equals 3 plus 12 is 15. Acceleration is A. Let me take this as my capital A equation. Completed, dear? So what should we do next? Somebody guess? What should we do next? Lamai? What should we do next?
Apply F equals ma to the 10 kilogram object.
Very good. We should apply F equals ma only to the 10 kg object. Only to 10 kg object. We must clearly indicate these things. Only to 10 kg object. Vertically downward. We are dealing with vectors. We must indicate the direction. We should apply F equals ma. There are two downward forces, there are two vertical forces acting on them. T2 acting upward, mg acting downward. So we apply the equation downward. Therefore, the resultant downward force is mg minus T2. mg minus T2 equals ma. M is 10, G is also 10, minus T2, M is 10 into A. A is the new acceleration, we don't know it. 10 times 10, 100, minus T2 equals 10A. Mark this as B. After that, just add A and B equations, then you will get the acceleration. Do it there. You are trying.
Okay, sir.
Have you found it there? I'll erase this side. Can you hear me?
Yes, sir.
Yeah. So let me add 1 and 2 equations. Sorry, A and B equations. A plus B. Capital A equation tells us T2 minus 60. Capital B equation tells us 100 minus T2 equals 15A plus 10A. Should understand that my positive T2 and minus T2 cancelled out. So remaining terms minus 60 and plus 100. 15 plus 10 is 25A. So I'll write the positive number first, then I'll write the negative number next. So you know these maths, but I have written it. I have written the positive number first, negative number next. 100 minus 60 is 40, equal 25 times A. If you take 25 this side, 40 divided by 25 equals A. So A equals 40 divided by 25 is 8. Sorry, 40 divided by 5 is 8. 25 divided by 5 is 5. So I would like to keep the answer in this format. I don't want to divide it because you should learn how to use fractions. It's a very good skill that you should learn. So acceleration is 805 meter per square seconds. Who got this answer? Who got this answer? Right, then how do you find the tension here? How do you find the tension? What should I do to find the tension?
Substitute A to another question, another equation.
Yeah, let's use this equation capital A. Let's use this equation capital A, then we can find the tension force. Look at both. Capital A equation tells us T2 minus 60 equal 15A. Can you do the rest and find T2, dear? Give a try. 15A. Give a try to find T2 by using the equation capital A. So T2 equals T2 minus 60 equal 15A. Acceleration is now 805. So T2 equals 15 divided by 5 is 3. This is 8. Minus 60 come to this side as positive 60. So then 3 times 8, 24 plus 60. 60 plus 24 means 84 Newton. So what is the new tension force in the string here? What is the new tension force in the string? Hello?
84 newtons.
84 Newton. Who got this answer? Who got the new tension force as 84 Newton? Okay, very good. Excellent. So that's the end of question number. I don't remember. Question number 18?
18.
Yeah. Shall we give
Yes.
a try for question number 19 and 20? Then we can go. Then we'll be able to go to a new theory part, new section.
Okay, sir.
Did you write all these things? Who wants more time to write? Anybody in the class? A bullet of mass 0.4 kilogram is fired towards the stationary wood block. The wood block is kept on a rough horizontal surface. The mass of the block is 0.6 kilogram. After the collision, the bullet gets embedded in the block. They move as a single object. The coefficient of friction between the block and the horizontal surface is 0.4. Calculate the velocity of the block with the bullet just after the collision. So what is the law that should be applied to find that velocity here? What's the equation that we should apply?
Law of conservation of linear momentum.
Yeah, we must apply the law of conservation of linear momentum. So for the question number 19, I think we have enough time to solve that problem. Let's give a try. If you are real students, you will stay in the class. Look at board. Question number 19. A bullet of mass 0.4 kilogram is fired towards a block. I don't remember the velocity. The block is at rest. Its mass is 0.6 kilogram. After the collision, the bullet gets embedded in the block. The bullet gets embedded in the block. It means the bullet will be at inside the block. The bullet will be at inside the block. Please draw this figure here, and they will start to move as a single object with a V meter per second. So at the time when the blocks start to move, do not worry about the friction. So we can consider friction later. So this is just, draw the figure here, please draw the figure. This is just before the collision. Just before the collision. And this is just after the collision. Please draw this figure here, quick. Let me mark the velocities. Don't remember. Yeah, bullet 100 meter per second. Block is at rest. Stationary block means block is at rest. Bullet moves with a velocity of 100 meter per second. The block is at rest. So what should we do to find this velocity here? What's the law that we should apply here? Somebody in the class?
The law of conservation of momentum.
Law of quantum.
Very good. So happy. So let's apply according to the law of conservation. According to the law of conservation of linear momentum. I can write that total linear momentum LM before the collision. Total linear momentum before the collision equals to the total linear momentum after the collision. Can you do the rest here? Can you do the rest and find the velocity?
Okay, sir.
Okay, sir.
I'm so happy with your comment there. Sir, we have discussed a similar question in the Sunday paper class. Yes, but what is the difference? What is the difference between the Sunday morning paper class question that we discussed? Very similar to this, but there is a difference. What is that difference here? Somebody? If you read the question carefully, you will find the difference. Yes, dear?
The wooden block is moving into the opposite direction.
Yeah, block was moving into the opposite direction. Here the block is at rest. But there's a huge difference than that. Try again.
It is tied to a string.
No string, yes. I'm so happy you remember my Sunday morning paper class, you see. So I should not worry about, because I'm not taking any fee for the Sunday morning paper class, but I'm very happy because you remember. One student said the block is, in the Sunday morning class, block was moving. Now the block is at rest. And the second student told me there was a string in the question. The block was hung by string. Very good. So you remember. So I'm so happy. That's the biggest thing that you can ever give to me. But the main thing is there is friction. There is friction there. See, the coefficient of friction between the block and the horizontal surface is 0.4. Find the friction force acting on the block after the collision. So you see, that's the difference there. Friction is also added into the equation. That's the reason. That's the difference. It will give a huge difference to this equation. Right. The total linear momentum before the collision is m1 into u1. The product mass into velocity is the linear momentum. If you are not learn linear momentum, if you not learn mechanics, you should join. You should stay in this class, right? Right. So m1, this is m2 into u2 equals, after the collision there are no two objects, there is only one object. The mass of that object is combination of the two objects is m1 plus m2. The velocity is v. m1 is 0.4, u1 is 100. m2 is 0.6, u2 is 0. u2 is 0 equals, m1 is 0.4, m2 is 0.6. The velocity is v. 0.4 into 100 is 40.0. 0 into anything, 0. 0.4 plus 0.6 is 1.0. So it means V equals, what is V here? Somebody unmute the mic and tell me, what is the velocity of the block with the bullet after the collision?
40 meters per second.
40
40
meters per
meters
second.
per second.
40 meters.
40 meters per second. Okay, dear? Right, after that they have asked the friction force acting on the block after the collision. So let me draw it here. If we draw this one, what is the total mass there? What is the total mass there? Total mass, capital M is 0.4, 1
kilogram. 1 kilogram, sir.
1 kilogram, yes, 1 kilogram, yes, 1 kilogram. Total mass is 1 kilogram. Therefore, the total weight is acting downward. If the total mass is 1 kilogram, the total weight is acting downward as capital Mg. The normal reaction force is capital R. It starts to move with the velocity of 40 meters per second, and there will be a friction force. there will be a friction force. Right, please draw this figure here. Please draw this figure. Because the next question is they have asked us to find the friction force. So draw it. Earlier I changed this, I have asked you to change 30 kilogram by 3 kilogram because it's a printing mistake here. Type, not a printing mistake, typing mistake. The 30 kilogram was a mistaken type. It should be 3 kilogram. Okay, dear. If you are disconnected earlier. So let's find R. We know that R is equal to mg because object is not moving up, it's not moving down. Therefore, the upward force should be equal to downward force. Then R and mg will be equal. Capital M is 1, G is 10. Therefore, R is 10 Newton. So we have found the normal reaction force. So how do you find the friction force? If the normal reaction force is R, what is the friction force here? What is the friction force? That is, friction force is mu r. Mu is the coefficient of friction. It is given as, I don't remember. The coefficient of friction. The coefficient of friction is given as 0.4. Coefficient of friction is given as 0.4. R is 10. 0.4 times 10 is 4 Newton. Roman number 3. What do you think about it? What do you think about Roman number 3? How much distance is traveled by the block when it comes to rest?
1,
How many kilograms?
1 kilogram.
1 kilogram. The mass of the block with the bullet, it's 1 kilogram. 1 kilogram. There is a friction force acting on it. We have found the friction force. What is the friction force, dear? How many Newton?
4 Newton.
Lamai, we
4
found
Newton, sir.
friction force.
4 Newton, sir.
7 Newton or 7 T.
4 Newton, sir.
I didn't hear you properly, Buddha.
4 Newton, sir.
4 Newton. Friction force is 4 Newton. What is the starting velocity, dear? Start to move with the velocity of
40 meters per second.
40 meter per second. So because of the friction force, the velocity decreases. And finally, the velocity will be 0. Because of the friction force, velocity decreases and finally it comes to rest. Bullet will also be there, friction force will also be there. The question asks us to find the distance traveled by the object, this S. So let me mark the acceleration of the object as simple a meter per square seconds. Now look at board carefully. The object is moving to my right hand side. As it is moving to the right hand side, I apply the equation into the right hand side. I apply the equation into the right hand side. I should apply the equation into the moving direction. But the force, the only force acting on the system is the friction force. I have applied F equals ma into the right hand side because object is moving to the right hand side. But the friction force, the only force acting on the object is the friction force. It is acting into the left hand side. So direction of the equation and the direction of the force are opposite. Therefore, when we deal with vectors, when the directions are opposite, we should use a minus sign. So it is minus 4 Newton. Mass is 1, acceleration is a. Take 1 to the, so nothing to do. So therefore, A equals minus 4 meter per square second. So we gotten acceleration is minus 4. What does it mean, dear? We found that acceleration is minus 4. What does it mean, dear?
A retardation.
It's known as it's a retardation. It's a deceleration. Okay, dear? Right, please write these things, dear. And is there any student who has not learned this law of conservation of linear momentum? Anybody in the class?
Sir said that we will learn about things in detail in the future, as we only did the linear momentum according to the second law of motion on the Newton's law.
Okay, so I'll teach this one, but I think you understood the law by doing this question, but I should give you a theory note, okay?
Okay, sir.
Draw the figure and find the acceleration, but actually it's not an acceleration, it's a deceleration. Did you write them all here?
Yes, sir.
Actually, this is not the same diagram, Buddha. We have not drawn this diagram earlier. This is a different diagram. This diagram shows the situation, the motion of the object after the collision. After the collision, bullet will be inside the block and the system has a velocity of 40. So both bullet and the block moves with a deceleration because of the friction force until it comes to rest. So we have not drawn this figure earlier. Okay, dear? Somebody has asked that question. Is it okay? We did not
Okay,
draw
sir.
this figure earlier. Right, we have not drawn this figure. This figure is in Sunday morning paper class. We did not do the calculations after the collision. So after the collision, we found the velocity. We did not worry about the motion after that. But here in this question, it discussed the motion of the block with the bullet after the collision until they come to rest. Okay, right. So to find the distance traveled by the objects, we may apply the equation v square equals u square plus 2a. S final velocity is 0. Initial velocity is 40 plus 2 acceleration. It's not an acceleration, it's a deceleration. That is minus 4. S is the distance. Can you do the rest and find this S, dear? Give a try. So what is the displacement here? 0 equals 40 square is 1600 minus into positive minus 4 times 2 8s minus 8s come to this side as positive 8s. This is 1600. Therefore, S equals 1600 divided by 8. So S equals 16 divided by 8 is to 200 meters. So that is somewhat impossible. Ne? Who got this answer? Who got this answer? Right. How they ask anything further? Shall we find the time taken also? Shall we find the time taken also? If we apply V equals U plus 80, we can find the time taken also. Am I right? You a try. If we apply V equals U plus 80, we can find the time taken for the motion. Final velocity 0, initial velocity 40, acceleration -4, time is t. -40 comes this side as positive 40 equal 40. So t equals 40 divided by 4. So it means t equals 10 seconds. Time taken for the motion is 10 seconds. Okay, dear? Okay, shall we go to next question, dear?
Okay, sir.
Can you give a try? Check your WhatsApp groups and give a try. Okay, so let's discuss. If we have not learned any theory related to this question, I'll teach them, don't worry. Question number 20. A metal ball of mass 1.2 kilogram is hung by a light inextensible string. The ball is kept at rest at B by keeping the string stretched as shown in the following figure. So this ball is at rest here. It is at a vertical height of 1.25 meters. So this is the string, it is at rest. So when the ball is released, it will be moved along a curved path and it will collide with this box. That's the first thing. The first question asks us to find the velocity of the ball when it reaches to the lowest position. So lowest position means it will reach to somewhere here because there is a string. So because of this string, the object will not reach the ground. So it will come to somewhere here. So let's give a try. Let's give a try. Can you guess the law that should be applied for question number 20? Anybody in the class?
Law of conservation of energy.
Yeah, we should apply the law of conservation of energy. Have we learned it in advanced level? Have you learned it with me? Why are you silent?
What do you
Right. So whether you
It
have
is, sir.
learned or not, I'll explain it. You will understand everything. Look at board. There is a string, right? There is a mass connected to the string. So the string is in the form of a straight line. That's why that's the meaning of stretch. By applying forces, the string is kept in a position of a straight line, stretched string. Initially, this object is at rest. So let me mark this point as capital A. The object is at rest. So if you release it, it will be moved along a curved path, right? And it will reach to the ground somewhere here, right? So this gap, if you check the question carefully, this gap is given as 1.25 meter. 1.25 meter is this gap. So when the ball reached to this point, its velocity, let me take as v1 meter per second. v1 meter per second is the velocity of the ball when it reaches to the lowest position. Lowest position. So at that time, let me mark this point as B, and this is the velocity before the collision of the ball with the block. So we are going to apply the law of conservation of energy from the point A to the point B. This is the first figure that we should draw for question number 20. They will not give marks for drawing figures in the examination. Then why do we draw them? They will not give us marks for the drawing of figures, but we draw the figures. Why? Yes? If we don't draw figures, we can't answer the question. We cannot understand the question without the help of a figure. Once we draw a figure, once we mark the given data, it's easy to solve the problem. That's why. Complete it here, draw the figure here. Whether you have obtained the answer or not, you should write my answers separately, right? That's the law. Draw it. Right. I think you have completed this. So let's write, let us apply the law of conservation of energy to the object from A to B. Let us apply the law of conservation of energy to the object from A to B. Let us apply the law of conservation of energy to the object from A to B. Look at board. Look at board. So that law tells us the total energy of the object when it is at capital E. What is the law of conservation of energy here? It tells that total energy is not changed. So if the object has a certain amount of total energy when it is at the point capital A, it has the same total amount of energy when it reaches to B. That's the meaning. So the total energy of the object when it is at A equals to the total energy. The total energy of the object. Total energy of the object when it reaches to B. So this is a solid object. This is a solid object. The total energy of a solid object is the summation of potential energy and kinetic energy. So total energy of the object at A means potential energy of the object when it is at A plus kinetic energy of the object when it is at A equals, please don't write, I'll give you the time to write. Listen to me, don't write. The total energy of the object when it reaches to B means potential energy of the object when it reaches to B plus kinetic energy of the object when it reaches to B. Potential energy is at A mgh1, kinetic energy is half mu square, potential energy mgh2 plus half m. What is the velocity of the ball when it reaches to B, dear? Somebody unmute the mic and tell me. The velocity of the ball when it reaches to B. What is it, dear? Lamai? Do we know the velocity of the object when it reaches to B, dear?
No, sir.
No. We have marked the velocity of the ball when it reaches to B as V1. Why didn't you tell me? It is, we don't know it. We have marked it as V1. So V1 is the velocity of the ball when it reaches to B, and that is the velocity when it reaches the lowest point, and V1 is the velocity just before the collision. So many meanings. So mg is 10 h1. Initially it is at the height of the distance to the object from the ground is 1.25. So initial height is 1.25 plus half m. Initially the ball is at rest 0. mg is 10. What is the final height to the ball from our selected level? What is the distance to the ball from this selected dotted line? Somebody please tell me. You have to think.
0 meters.
0 meters. This is a dotted line. This we measure all the heights from this dotted line. We measure all the heights from this dotted line. So the initial distance to the object from this selected dotted line is 1.25. Therefore, h1 is 1.25. But now object is on the dotted line. Therefore, distance to the object from the dotted line is 0. Therefore, h2 is 0. Plus half mass is m. The velocity is v1. Do we want m, dear? Do we want? Should we know the mass m, dear? Somebody unmute the mic and tell me. Should we know the mass M
So the mass,
or sorry dear?
it's given. The mass is given, sir. in the
Yeah, mass
question.
is given, but do we want it for this calculation?
No, sir.
Why not?
We can cancel it out.
Very good. We can cancel out all the terms. M can be cancelled out. So as all the M terms are cancelled out, we don't M even it is given. So please write them all. Try to find the velocity we want. Give a try. So what are the remaining terms here? 10 and 1.25 is there. 10 into 1.25 is there. Plus half into 0 square. 0 into anything, 0. Equals 10 into 0. 0 into anything, 0. Plus half into V1 square. Half into V1 square. 10 into 1.25 is 12.5 equals half V1 square. Then take 2 to this side. Then we will get 12.5 times 2 equals V1 square. 12.5 times 2 is 25 equals V1 square. Therefore, V1 equals, if V1 square is 25, V1 equals square root of 25. Then we will get V1 equals 5 meter per second. V1 is 5 meter per second. Who got this answer? Anybody in the class? Now we should try for the next question. The next part of the question, Roman number 2, an object, let me show you that question. We have answered Roman number 1. We are going to answer Roman number 2. I'll give 1 more minute to write the answer, these answers. After that, I'll read question number 2, Roman number 2. Right, let's go to question number 2, Roman number 2. Roman number 2 says, and another object of mass 1 kilogram is kept at rest on a rough horizontal ground as shown in the above figure. If the collision between the ball and the object is elastic, what does it mean there? what is the meaning of the word elastic there? The collision is elastic. Collision is elastic means if this must be separately given. If it is given that collision of a certain collision is elastic, its meaning is no waste in kinetic energy. It means kinetic energy before the collision and kinetic energy after the collision will be the same. That's the meaning of elastic. What's the meaning of the elastic there? The total kinetic energy of a system before the collision and the total kinetic energy of a system after the collision are equal. There is no waste in kinetic energy. That's the meaning. So an object of mass 1 kg is kept on rough horizontal ground as shown in the above figure. If the collision between the ball and the object is elastic, find the velocity of the object just after the collision. So what is the mass of the ball here? What is the mass of the ball? A metal ball of mass 1.2 kilogram. Mass of the block is 1 kilogram. So we want to find the velocity of the object just after the collision, because they have given that collision is elastic. And finally, they have asked some other questions also asked. Let's give a try here. Right, so we have found that the velocity of the ball after the collision is 5 meters per second. So I want to erase these things. If you want, please take a screenshot. If you want any more time, please take a screenshot. Right, the velocity of the ball just after the collision is 5 meters per second. But this block is at rest. So it means its velocity is 0. So this is the situation just before the collision. This is the situation just before the collision. They have given us the masses. Mass of this object is given as 1.2 kilogram. Mass of this object is given as 1 kilogram. So after the collision, the two objects will start to move with two different velocities. This will start to move with the velocity of v3 meter per second. This object will start to move with the velocity of v4 meter per second. So actually this question asks us to find this v4. This question asks us to find this velocity v4 just after the collision. Right? So masses are m1 and m2, they are given. Please draw this figure for Roman number 2, dear. So actually we should find both v3 and v4, but first they ask us to find v4. Give a try, dear. Draw the figure. No, not to give a try. Just draw the figure. I'll do the question. I'll ask the question. You just draw the figure and wait. Right. So it is given as the collision is elastic. So please write just below the figure. If you want, you may it's a star point. Please write. It is given in the question that the collision is elastic. It is given in the question that the collision is elastic. It is given in the question that the collision is elastic. It is given in the question that the collision is elastic. Therefore, there is no waste in kinetic energy. It is given in the question that the collision is elastic. Therefore, there is no waste in kinetic energy. Therefore, there is no waste in kinetic energy. Clear? So leave a line and write. So what have I said? What I have said? It is given in the question that there is no waste in kinetic energy. Therefore, we can apply. The collision is given as elastic. There is no waste in kinetic energy. Therefore, we can apply the total kinetic energy. The total kinetic energy before the collision. The total kinetic energy before the collision equals, don't write, the total kinetic energy after the collision. Total kinetic energy before the collision equals total kinetic energy after the collision. Right? So total kinetic energy before the collision means summation of the kinetic energy of the ball half m1 v1 square plus kinetic energy of the block half m2 v2 square, even though v2 is 0. Total kinetic energy after the collision is half m1 v3 square plus half m2 v4 square. Can you do the rest and try to obtain a relationship between, try to subject v3 square and v4 square? Give a try. This is okay. Try to subject v4 square. Substitute the values given in the question and try to subject v4 square. Give a try. So mass of the block is given as 1.2. So you should understand that all the half terms are cancelled out. Please remember that you can apply this equation only when it is given that collision is elastic. Then only you can write total initial kinetic energy equals total final kinetic energy. It must be given in the equation that the collision is elastic. Then only you can apply this. Right. M1 is 1.2, V1 is 5 square, plus M2 is 1, V2 is 0. M1 is 1.2, V3 we don't know. M2 is 1, V4 is V4 we don't know what the V4 is. So what are the remaining terms there? 1.2 into square of 5 is 25 plus 0 into anything 0 equals 1.2 times V3 square and V4 square plus V4 square, because all the half terms are cancelled out. 25 times 2, 50. 25 times 1, 25 plus 2, 25 times 2, 55 remains. 25 times 1, 25 plus 5, 30. One decimal point should be removed. Equals 1.2 V3 square plus V4 square. So let me take 1.2 times V3 square to this side. So it will be 30 minus 1.2 times V3 square equals V4 square. So let me mark this as the first equation. Who got this equation without my help? Anybody in the class? Hello? Is there anybody who has subjected V4 like this? Can you hear me at least?
Yes, sir.
Yeah, so please write up this point. That if you have any doubt, please ask. So this question somewhat mathematical. Maths is there. This is the final question of which is given under Newton's laws of motion. And another set of questions given from Newton's laws of motion at the end of the due.
Okay, sir.
Okay, let's give a try. So can you guess the next law that we are going to apply for this question? What should we do next? Somebody? Lamai? You know the next law that can be applied to solve this problem. You must be able to tell me. Even in the previous question, we applied it. Yes? What's the law that we have applied in the previous example, dear? The bullet and the block question. Tell me.
Law of conservation of linear momentum.
Law of conservation of linear momentum. So here also we are going to apply the same theory. So please write, let us apply the law of conservation of linear momentum. Let us apply the law of conservation of linear momentum. So this is what we have written in the previous example. Am I right here? I have said let us apply the law of conservation of linear momentum. The law of conservation of linear momentum tells us the total linear momentum before the collision equals total linear momentum after the collision. Linear momentum is the product of mass into velocity. Linear momentum has a direction. If an object is moving to a certain direction, its linear momentum is also into the same direction. So linear momentum of the first object is into this direction, m1 into v1. Linear momentum of the second object, the product mass into velocity v2, we must use the same direction for all the terms. We cannot change the direction. Once we select a certain direction, that direction must be applied to all the terms. After the collision, m1 into velocity of m1 is v3. m1 into v3 is the linear momentum of the ball after the collision. Linear momentum of the block after the collision, m2 into v4. m2 into v4. So the direction should be the same. So please substitute the numerical values that they have given and try to subject v4. Try to subject v4. Give a try. If you have any doubt, you can unmute the mic and ask, right? I'm here. I'm always here to help you. Right, M1 is given as 1.2. M1 is given as 1.2. V1 is given as 5. V1 is not given, actually we have found V1 as 5 meter per second. M2 is 1 kilogram, but V2 velocity is 0. M2 is 1, but velocity V2 is 0. Plus M1 is 1.2. We don't know what the V3 is. M2 is 1, the velocity is V4. 1.2 times 5, we know that 12 times 5 60, but one decimal point should be removed, therefore 1.2 times 5 is 6.0. 1 into 0, 0 equals 1.2 times V3 plus 1 into V4 is V4. So as usual, I'll take 1.2 to this side. 6 minus 1.2 times V3 equals V4. This is the second equation. Who got this equation, dear? Anybody in the class? Now we have a big problem, dear. What is the problem that we face, dear? In the first equation, V3, V4 terms are in square format. V3 square, V4 square. Am I right, dear?
Yes.
In the second equation, we have only V3 and V4 without square terms. So what should we do to make the second equation to have square terms? What should we do, dear? I want square terms of V3 and V4. So I want to change the format of the second equation. So what should I do to make V3 and V4 square in the second equation? Think. Hello? Can you understand my question here? Lamai. Here we have V3, V4. Here we have V3 square and V4 square. So what should I do to make this V3 and V4 into square terms, dear? What's the method that we should use?
Powers.
Yeah, we want the second power of V3, second power of V4. So what should we do? You have forgotten O-level maths, ne? The easiest thing is just get the square of the second equation. Square of the second equation means 6 minus 1.2 times V3 square of this side equal to the square of the other side. Is it clear? So what should we do here? What should we do to make V4 and V3 square? Tell me.
Square the equation.
Square the equation. Now O-level maths. What is x minus y square here? Somebody please tell me.
X squared minus 2xy plus 5 squared.
X square minus 2xy plus y square. Similarly, if I consider x as 6, y as 1.2 times V3, so what will be that square here? I take x as 6 and y as 1.2 times V3. So then how do you write the square terms here? Tell me, dear. You are right.
36 minus.
Yeah, x square, 6 square. So 6 square is 36, but let's write it as 6 square minus 2. Next term. X square 2. What is x here? 2xy. What is x? You have to talk there. Can you see the equations?
Minus 72 over 5.
Do not multiply, dear. I do not multiply. I ask what the x is. What is
6.
x?
6.
May 6. Y?
1.2.
What is y?
1.2, sir.
1.2 times V3. Y is 1.2 times V3 plus y square. What is y?
1.2. 1.2 V3.
1.2 times V3 square. Look at board. X minus y square is x square minus 2xy plus y square. X is 6. Therefore, x square means 6 square. Y is 1.2 times V3. Therefore, 2x is 6. Y is 1.2 times V3. plus y square. Y is 1.2 times V3. Therefore, y square means 1.2 times V3 square. Got it? Is it clear or may I again explain?
It's clear, sir.
Right. So then x square means 6 square minus 2x is 6, y is 1.2 V3 plus y square means 1.2 times V3 square equals V4 square. 6 square is 36 minus 6 times 2, 12. 12 times 2, 24. 2 remaining. 12 times 1, 12 plus 2, 14. So 14.4 because one decimal point should be removed. V3 plus 1.2 square is 1.44 into V3 square equals V4 square. This is our third equation. Check whether the simplifications are correct. Check whether I have simplified correctly and write the note also. Quick. Okay, dear. Are all the things clear, dear? Are you okay up to this point? Are there any errors in the calculations or simplifications?
No, sir.
Is everything okay?
Yes, sir.
Did you write the note also? The red color note? The x minus y square case?
Yes.
Right, now the simplification is now straightforward. Just look at board. The third equation tells us, I'm going to combine 3 and 4 equations. Sorry, 3 and 1. 3 and 1. The third equation tells us 36 minus 14.4 times V3 plus 1.44 V3 square equals V4 square. Am I right there? This is what third equation tells us. Third one. But according to the first equation, V4 square is equal to 30 minus 1.2 times V3 square. So the next step, 36 minus 14.4 V3 plus 1.44 V3 square equals V4. V4 is, according to the first equation, 30 minus 1.2 times V3 square. So let me write the square. Okay, I'll do something like 36 minus 14.4 V3 plus 1.44 V3 square minus 1.2 come to this side as positive 1.2 V3 square. Am I right there? Minus something comes to this side as positive something. Positive 30 comes to this side as negative 30. Are you okay? And what are the remaining terms here, dear? What are the remaining terms here at this side?
0.
0. No remaining terms. There are no remaining terms. The two terms taken to this side. What do you think about 36 and minus 30, dear? So when you write the note, also use some arrows like this. 36 minus 30. What's the answer?
6.
6. Minus 14.4 V3 plus V3 square common. 1.2 and 1.44 added. Both are plus. 4, 2 plus 4, 6. 1 plus 1, 2. 2.64 times V3 square equals 0. Am I right there? Okay, please write up to this point. After that, I'll explain how to do the further simplification. First, you write up to this point here, then I'll explain. Right. So then I'll write the square term first. 2.64 times V3 square is written first. After that, I write the minus 14.4 V3. Finally, I write this plus 6. 6 is positive. Okay. What can we do next, dear? Now, this is a normal quadratic equation. So what can we do next?
Finding factors.
Yes, dear.
Factors.
Yeah, we have to factorize, ne?
Yes, sir.
The simplest thing is all the numbers 2.64 can be divided by 2. 14.4 can be divided by 2. 6 can be divided by 2. 0 can be divided by 2. So what are the remaining terms then? If we divide, what will be the terms then in the next step? 2 divided by 2 is 1. 6 divided by 2 is 3. This is 2. 1.32 V3 square. 14 divided, this is V3. 14 divided by 2, 7.2 V3. 6 divided by 2 is 3 equal 0. Okay, dear, please write up to this.